So this video is a continuation of the 7.8 worksheet. So now we want to determine the measure of the angle in radians indicated on this circle. So notice here that we are given both the x value and the y value. I also want to highlight that this point is in quadrant 3. So just a quick refresher, when we look at the sine function, that's the vertical distance, our point can be in quadrants 1 or 4, but for the cosine function, our point can be in quadrants 1 or 2. This particular point is in quadrant 3, so that means that no matter which function we choose, we will have to use the reference angle. So with this particular problem, because we are given both the vertical and the horizontal distance, that means we can use either sine or cosine. I'm actually going to show both of those kind of simultaneously, but you really only have to do one or the other. So let's start with the x value for the horizontal distance. So x equals r cosine theta. The x is negative 4.885 equals, the radius we know is 6 because they're telling us that this point right here is 6, 0, cosine theta. And then very similar, let's look at the sine function. So again, remember, we only have to do one or the other. So we've got y equals r sine theta. The y value is negative 3.484 equals radius is 6 sine of theta. Okay, now we want to get the cosine theta by itself. So divide both sides by 6. Same thing with our sine function. We're going to divide both sides by 6. Okay, now we want to isolate our theta, right? We're solving for that angle measure. So that means we need to take the inverse of both of those. So the inverse allows us to switch our inputs and outputs. So this becomes cosine inverse of negative 4.885 divided by 6 equal to theta. And very similar here, the inverse switches our inputs and outputs, so we get sine inverse of negative 3.484 divided by 6 equals theta. Okay, so remember our domain for the cosine function is going to be in quadrants 1 or 2. Okay, so when we plug this into our calculator, we get theta is equal to 2.52. And remember, cosine is horizontal distance, so that means it's giving us this point right here, and it's giving us this angle, so 2.52. Oh, and I should highlight that this is in radians. So what I encourage you to do is in your calculator, go to mode, switch it to radians. Because if you look at our directions, it says determine the measure of theta in radians. So we want to make sure we're in that mode. Okay, so going back to our picture here, the cosine gave us the point in quadrant 2, but the point on our problem is in quadrant 3. So we need to use our reference angles. Okay, so there's multiple ways to kind of reason through. I'm just going to be showing one of the ways, but if you have a different way of reasoning through, you can absolutely do that. So this 2.52 by symmetry means that this right here is also going to be 2.52. And so when we think about getting to this line right here, this terminal side of our line, let me switch colors. We want the angle from the 3 o'clock position all the way around to that terminal line. And so what we can do is take the full circle, which is going to be 6.28 or 2 pi, and we want to minus the 2.52. And when we do that, we get 3.76. Okay, so that means that our angle from this 3 o'clock position all the way around is going to be 3.76 radians. Okay, let's also take a look at the reference angle if we were using the sine function. So our sine function, when we plug this into the calculator, we get our theta is equal to negative 0.62. And remember that when we're working with the sine function, that gives us values in quadrants 1 or 4. So in this case, the reference angle to our given point, so here's our given point. The reference angle is going to be in quadrant 4 because they have the same vertical distance. Because the calculator gave us this angle right here, we know that this is going to be 0.62. The reason why it's negative is because we went in a clockwise direction, but that means that this little angle right here is going to be 0.62. And by symmetry, that means that this angle over here is also going to be 0.62. Okay, and since the angle that we're looking for always starts from the 3 o'clock position and goes all the way to this terminal side, we want all of this angle right here. And notice that that is half of the circle plus an additional 0.62. So half of the circle in radians is 3.14 plus the additional 0.62. And that also gives us 3.76. Okay, so again, you only needed to do the cosine or the sine, and we ended up with that same solution of 3.76 radians. All right, let's go ahead and do another one together. So on problem 13, we've got a skier skied on a circular trail starting at the position 2.5, 0. Okay, that information tells us a few things. Tells us that we're starting at that 3 o'clock position as usual. And it tells us that the radius is 2.5. Continuing on with our word problem, we know that the skier ended at the position negative 2.3775, 0.7725. So let's go ahead and plot that on our graph. We know this point right here has our radius of negative 2.5. So if we're at negative 2.3, that means we are super close to that negative 2.5. So there's negative 2.3775. Okay, and then the y value is 0.7725. It's positive, so that means we're going to be up here. So if you need to, you can draw in some tick marks. So there's 1, 2, and then that'll be about 2.5. Right, and then our 0.775 is going to be about right here. Okay, so that tells us that this right here is approximately our point. And these don't need to be drawn perfectly. We just kind of want to get a rough idea of where that point actually exists. Okay, so this right here marks where the skier is located. And we want to know how many kilometers did the skier ski. Okay, so this is actually looking for the arc angle. Okay, that was our value S. That was the letter we had used in a previous worksheet. And remember, our relationship is arc length equals theta multiplied by r. Okay, well, in order to use this, we could also put in the letter S there. So S equals theta multiplied by r. Well, right now, the only thing we know is the r value. We do not know our theta. So in order to answer this question, we need to find our theta, which is what we just learned how to do. Okay, so let's go ahead and do that. So drawing a line from the skier to that origin, we are looking for this angle right here. Okay, Okay, and notice that our skier is in quadrant number 2, which if we go and look at the sine and the cosine functions and their corresponding domain, we know that the cosine function gives us the value when our point is in quadrant 2. Because we are using the cosine function, let's set up our equation. So cosine, remember, is using that horizontal distance. So that's going to give us the x value equal r cosine theta. The x value in this case is negative 2.3775 equals the radius is 2.5 cosine theta. Okay, so just like before, we're going to divide both sides by 2.5. And then in order to get our theta all by itself, we are going to take the inverse, so that way we can get the theta all by itself. So this now becomes cosine inverse of negative 2.3775 divided by 2.5 is equal to theta. Okay, so then when we plug this into the calculator, we get our theta is equal to 2.827. When we get this answer, we do not need to do anything with a reference angle because we use the cosine, and remember our cosine gives us a value in quadrant 2. If we had used the sine function, then yes, we would have had to do a reference angle because the sine function would have given us an answer in quadrant 1, and so then we would have had to do the reference angle. Okay, don't forget, we are not quite done with our problem. All of this work just gave us our theta value. And remember, our question is we are looking for the arc angle. So now we're going to come back up here. We're going to take this equation and we're going to plug in the theta, which is 2.827, multiplied by our radius of 2.5, which gives us an arc length of 7.0675. So that means the skier traveled 7.0675. Our units are in kilometers. So that means when our skier starts at the 3 o'clock position and travels around this circular trail, they will have traveled a total of 7.0675 kilometers. What I want you guys to do for problem 14 is you will notice that there are 3 parts, but all 3 of those parts have the same point, but just located in different quadrants. So I want you to try these on your own. I want you to find the angle measure of each of those points. Okay, I'm going to go ahead and just show the solutions for these 3 parts. So in part A, you should be in quadrant 3. So this one, it does not matter if you use sine or cosine for the solutions. I'm going to go ahead and show the solution for cosine, but if you use sine, you should still get the same answer. So you should get a theta of 2.06, and then with some symmetry, you get your theta of 4.22. And then don't forget, this question was looking for the arc length. So we're going to take arc length equals r times theta, which means we're going to take 4 multiplied by 4.22, and we get 16.88 meters. On part B, we are going to be in quadrant 2. So because we're in quadrant 2, it is best to use the cosine function. Okay, and you should get theta is equal to 2.06. And then again, because we're in quadrant 2, we do not need to do the reference angle. And then don't forget to finish out the problem. The arc length is equal to 4 times 2.06, which gives us 8.24 meters. Okay, and then on part C, this point is in quadrant 4, which means that using the sine function would be best because the domain of our sine function is in both quadrants 1 and 4. Since our point is in quadrant 4, let's use the sine. Okay, and then one thing to be careful of here is that our solution for sine is negative 1.08, but we want to make sure that we're thinking about it in the positive direction. So that means we want to actually do the complement of that. So we're going to take our theta of 1.08 and subtract it from 6.28. Right, so that way our theta is positive when we plug it into our arc length function. Okay, so our sine function gave us a solution of negative 1.08. So then we take the complement of that so that our theta is going in a clockwise direction, which gives us 5.2. And then don't forget, we're going to plug that into the arc length formula. So arc length equals 4 times 5.2, which gives us 20.8 meters. All right, that is it for this worksheet. Let's talk about some of the big ideas. Okay, so big idea is that our sine function, we restrict the domain so that we are in quadrants 1 and 4. Our cosine function, we're going to restrict the domain so that our solutions are in quadrants 1 and 2. And we do that so we can find the inverse. Okay, if we didn't restrict the domain, our calculators would give us an infinite number of solutions. So we have to restrict the domain so we only get one answer.